G'day there again, everybody. I'm going to have another attempt at running Joule thieves in series today. This time it's going to be a forwards Joule thief into a forwards Joule thief, and we're going to use a PNP transistor to do it. I don't know if it's going to work or not. I haven't actually tried it successfully yet. I got halfway and I think it's going to work, so I thought I'd do this video and take you through it step by step. So what I have running here is just a standard NPN Joule thief. It's running off the copper part of this coil here. As you can see, the steel ends are not connected to anything. Just the copper's connected up. It's a really simple circuit. I've got positive straight to the centre tap. One side goes through a pot into my base to control the oscillations. The other side goes straight to the collector to provide the power spikes, and that's what you can see here. The blue line's the base. That flat bit's where the base is switched on. And then the power drains out through the other side of the coil too much and switches the base off, and the induction coil collapses, causing that big spike at one end of the coil and the big negative spike at the other. If I turn my potentiometer, it will adjust the frequency and power of that until it dies. Okay, so it's a standard and as simple as can be NPN transistor Joule thief. I'll just put you down the tripod for a sec, because I'm going to need two hands. Try and get as much on the screen as possible. Now what I want to do is I'm going to use those negative spikes that are on the base to activate a PNP transistor, which is going to divert power from my collector here. So I can run a second circuit out from my collector and into my emitter, or my negative terminal of my battery, without interfering with the first Joule thief. And I'm going to do it using this coil over here. So before we do that, before we hook anything extra up, let's just leave this one running as is. And let's have a look at what's going on in this coil, because that gives you a really good idea of the magnetic induction that's going on. Oops, I've just lost a negative probe. Chuck him back on there. And therefore go on that one. There we go. Now, this will give you a good idea of what's happening in your ferrite cores that you normally wind these Joule thieves around. If we have a look at this scope here, I'll try and get that a bit neater for you. Well, you can see I'll just pause it because it is jumping around a bit. The two ends of the coil are always directly opposite to each other. It's oscillating. So when one end of the coil goes positive, the other end goes negative. And it's doing it with some harmonics. I think we'll find that my scope, it's got about a megahertz bandwidth. I think this is flashing a lot faster than a megahertz, so my scope's probably just picking up some kind of subharmonic. And that would explain a lot of that jumpiness. Even if I'm moving the trigger around, it's really not going to steady out that well. But I have learnt something already that'll be useful in making my next circuit. Let's just drop that voltage scale back at it, to where it's a bit more valuable to us. Get that trigger down, it'll all come nice again. There we go. And time scale back out. Now what we're seeing here in this view is I have both channels on the same baseline. So the yellow line is going more negative and the blue one is definitely going more positive. That's going to be useful information for later on. So if we go and look at our coil, I can see here on my scope my red probe's in channel B and my grey-green scope is in channel A. So that one's yellow and that one's blue. That's going to come in handy later. Now what I want to do here is I'm going to take this, what do we got, BC578 PNP transistor, and I'm going to put the collector in the same position as the collector of the other transistor. I did try putting the base on the same part earlier. It does not work. What you need to do to get that base to fire is use a diode. And I tried a germanium and a Schottky, and actually a 0.6, 0.7 diode seems to work alright. So, and you want the cathode of that diode towards the base of your NPN, and the anode towards the base of your PNP. You do notice there is some dimming there, but what we can now do is get a second LED running. Not the same brightness. The brightness has probably been shared out between the two of them now, but that's okay because that's what I wanted. I can now run a light off my first Joule thief, and without affecting that I can also run a second load independently, and it is being switched, and we can look at that on the scope if you like. I'm sure someone will like, so we're going to do it. And I've got loose connections everywhere here, so please bear with me. We want to do yellow, can go on that one. And I don't know why, but I really like the blue colour on my primary base. It's just what I'm used to. Now, why aren't you oscillating? Loose connections everywhere. I might cut this off here and I'll sort out my connection problems and make sure this is all working properly, and we will come back and I'll show you what the oscillations between the different parts of the transistor look like on the scope. Stay tuned and I will be back with some editing soon. Okay, I'm back. I fixed it. My scope had pulled a transistor out. So, what we have here, yellow line is on collector. Hopefully it's going to focus for those of you that want to see the numbers. Yellow line is on the collector of the NPN. The blue line is on the emitter of the PNP. So I have a nice little output voltage there off that PNP that I can use for something else. And while we're looking at that, I'm just going to unplug the LED and see if that spikes. Oh, look what happens when my finger touches the LED. It's still plugged in. It's just my finger holding it. And unplugged, and we do get a slight spike with the LED unplugged. I'm going to get it back in the right hole. There it goes. And that's very interesting that it dives like that when I touch it. That's my finger on the positive, on the anode of the LED. Let's see if I can do that where you can see what's going on. It's not real consistent, but that's interesting. Obviously my body's capacitance or grounding is providing something there. So I'll just bump that back in so that we know it's running. That's my idiot light that tells idiots like me that it's actually turned on and working. So we know from our little test before that this side of the coil is more positive and this side is more negative. Here's our centre tap. So let's look at that while we hook it up, and hopefully I'll do this without knocking anything loose this time. Got it. These clip leads and stuff are great when you want to change things around really fast, but they're also really annoying. So let's chuck that onto there. So as we can see, we've got those same. That's just the magnetic oscillation in the core here, caused in the steel core, caused by the oscillations of the copper Joule thief that's running. Now let's hook this up, output up to our centre tap. Oh look, that changed the scope. Let's see if we can move that trigger around and steady that out. I reckon we go for blue. And if I lift that up, okay. So we definitely have, again, the north blue end of my coil is definitely a bit more positive than the other end. And that's the output we're going to be trying to run the second Joule thief on. So let's look at these max-min figures here. Yellow's got voltage DC of 1.3, a max of 1.7, RMS of 1.16 and P2P of 1.8ish. Channel 2 is definitely blue, is definitely quite a bit higher, so I'm going to put the base on the yellow one. Right, so that's the purpose of looking at that like that. It's so you can work out which side your base is going to work better at. I'm going to get much higher spikes off the blue end of that coil. So I'm going to do some more setting up and I will come back and edit in some more video in a bit. See you soon. And eureka, it works. I have my probes hooked up to the collector and base of that transistor on the second Joule thief running off the steel core of the first Joule thief. And we have oscillation, people. It's working. First try. How cool is that? Not that hard after all. In 2 days I've designed 2 different Joule thieves that run off each other. I'm not even going into using capacitors yet. Just wait till I start filling capacitors up. I'll be able to run heaps of these things in series. Let's fire up that 250 volt one again. I'm just joking. We might wait a little bit before we amplify the buggery out of that. So I don't really know where to go from here. It works. Oh, let's have a look at output of first Joule thief compared to second. So blue line is second Joule thief, and yellow line is first Joule thief. Look at the difference in durations in the squiggly bits. I'll work out what all that means later. The squiggly bits are magnetic resonance coming off that core. It's probably because it's steel wires, probably not the best way to make a core. It'll be sloppy as. But it does work. I like doing these things rough sometimes, because if you do it really rough and it works, then you know you can get a really good neat one going. Anyway, thanks for watching. Oh, one last thing I should add quickly before I go. I put a pot, a second pot. I have a 25k, 50k pot on the base of the second Joule thief. 500k, which is way too big on the base of the first one. Hardly turned it goes out. But I'm just going to give you a reasonable view of the scope here if I can while I play with the pots for a second. You can see that it does indeed. Let's see if we can zoom. Is that going to focus? Oh, look at that. Very nice. So this is a 50k pot on Transistor on Joule Thief 1. That is maxed out. That is minimum resistance. That's pretty much 0 ohms. There might be a tiny bit there, but that's with it turned all the way. Those dips are because my hand are on the knob. I just took the hand off the knob, the dips stopped. Now let's start adding some resistance. Look at that. I get a longer, more efficient waveform. Now I wonder what happens if I try and retune the first one a little bit. Whoa! I don't know if you can hear that, but it's now ringing. That's a big waveform. That's quite a difference in scale at the time. I suspect the battery's going to go really flat really fast if I leave that going that hard for long. And that is really bright too, I might add, on that first Joule Thief. And that is an old flat battery. I've used this in lots of tests before. If we have a look at the end of it, you'll even see that I've... Where are we? Oh, I'm zoomed out. Zoomed in, that's right. If the camera's going to focus on that end, you'll see I dinted it. And I actually sit it on some magnets and run a little DC brush motor on there. But that's tunable. And both coils can be tuned sort of reasonably independently of each other. Getting some nice notes out of this. She really squeals. Second one seems like a lot of resistance. First one not so much. It's pretty good in there somewhere. Anyway, it works. Thank you for watching. Hope you enjoyed and learned. See you next time.